go. I'm sorry about the delay. I was dumb and was setting up in the wrong room. And off we go. And I forgot to bring my clicker, so I'm going to stand here and click the mouse or the trackpad. So thank you all for coming. There are a lot of good talks going on, and it's always nice when people think yours is good enough to drop in on. So we'll try to make it worth your while. Normally, so I'm Chris Larsen. I'm a researcher with Symantec, formerly with Blue Coat, and got acquired. And normally when I'm doing a presentation, I'm talking about my own research primarily. This talk is different. It's very collaborative because I wasn't aware of much happening in the IPv6 threat landscape, and so I reached out to a number of other researchers and kind of pooled the war stories. And so that's why it's a better talk than it would be if it was just me doing it. So I wanted to really quickly do a couple of slides and talk about kind of ancient history, IPv6, and modern history. So these are the milestones according to me. Okay, this is the stuff that I thought was significant. We knew clear back in the dark ages that we were going to run out of IPv4 addresses, and 2 billion would have done us more if we'd done a better job of intelligently handing them out, but we didn't. There were some early warnings, the 2005 paper from US CERT and the 2010 paper from NIST, warning kind of about the problems that could arise. The IPv6 was designed to be more secure than IPv4 in some ways, but it also opens up new opportunities for attackers, and so they tried to address those. But things really got rolling in the US in 2010 when the government decreed that all government infrastructure and websites and all of that stuff, all networks needed to support IPv6 by 2012. And so you had this crazy fun day in 2011 was World IPv6 Day. Just by show of hands, did any of your organizations participate in World IPv6 Day? One, yeah. So basically a number of big tech properties and companies who made different kinds of infrastructure stuff set up IPv6 versions of their website and their DNS and their network, and then they would see if we could talk to each other. Yay, it works. And then that worked well enough that we had World IPv6 launch day a year later, and everything worked and we all shook hands and went home. And so it was like, okay, everything's under control, IPv6 works, and we went on to other things. So to understand where we're at now, the best paper that I found, in terms of best being most interesting, because I don't like boring stuff, was this paper that compared IPv6 adoption in China and Australia. And Australia here is a proxy for the US and Europe, kind of the Western world versus Asia sort of thing. So Australia ended up, when the great IPv4 land rush was over and everybody had their addresses, Australia has about 47.5 million, and that's for 22 million people. So every man, woman, and child in Australia has a little over 2 IPv4 addresses, okay? And, okay, so how many websites does the average person need? Okay, so you've got probably enough. There's not been a lot of pressure in Australia, and by extension, the rest of the Western world, to have to move to IPv6, other than mandates, from things. In China, they ended up with 330 million IPv4s, and that sounds like a lot, but when you divide that among 1.3 billion people, it's less than 1/8 the per capita IPv4s that Australia has. And so that's why China has, and other countries in Asia, have had huge pressure on them to move to IPv6. And there were a bunch of slides. By the way, there's you can go to the RSA conference site and search for IPv6, and you can find the longer version of this talk. I'll also stick a link somewhere on SaintCon, and if you're doing capture the flag stuff, you'll be able to find my link. But I'll highlight in a couple things in this slide. If you look at the percent of infrastructure or deployment, T-Mobile and Verizon are in 80-90%. And back in that 2010 era, when I was talking with a colleague who's one of the world's IPv6 gurus, and I said, okay, I get that we're going to run out of IPv4 space eventually, but what's the big deal? And he said, Chris, there are already mobile phone providers in China using 2 levels of 10.NAT addressing to run their infrastructure. That kind of melted my brain. I've not fully recovered. But you see that a lot of the mobile phone infrastructure is already IPv6. The odds are really, really good that you have in your pocket or your hand, if my talk's too boring and you're playing a game, you have an IPv6 enabled device. Okay? So, but a lot of people, when I started getting material for this talk together, a lot of the researchers said, oh, let me know what you find out, because I've wondered, what's going on with IPv6. And some said, well, isn't that already rolled out and working? And we hadn't noticed. So one of the problems you run into in the West is we haven't had to move to IPv6, and so we haven't. And so a lot of the typical IT people, yeah, there's maybe a checkbox item where they turned it on or turned it off, but that's the extent of it. And when you actually start trying to play with IPv6, you run into rough edges. And so this was, when I asked for more war stories this time around, somebody pointed me to this. And so Microsoft was doing a guest Wi-Fi network, and they said, well, let's make it all IPv6. Whew, futuristic. Until one of their team members went to a conference that was using IPv6 only Wi-Fi for the guest internet access, and nobody could get their VPN client to work. And they found out, oh yeah, VPNs fail on IPv6 only networks. Known issue. Oops. So the Microsoft guys said, don't we haven't given up. We're still testing. We're going to make this work, right? But that's the thing. So normally the network, your appliances, the OSs you're running, everything kind of supports IPv6, at least in theory, that should. But when you actually try to get something working, it's a big problem. One of the things we were doing research earlier this year, way earlier this year, we turned on IPv6 in part of our lab, and of course we had to go through this whole big rigmarole process to get permission to use IPv6 because it's dangerous. And I said, if you can point me, I'm a security guy, if you can point me to any competent article that says that IPv6 is more dangerous than IPv4, I would really like to use it in my talk. Crickets. For the record, IPv4 is a lot more dangerous than IPv6 in terms of where the bad guys are active. So anyway, we turned on IPv6 in the lab and promptly broke Ubuntu updates. Waylon's laughing. Because when you turn on IPv6, there's a whole lot of things that suddenly say, oh, IPv6, I'll switch to that. And then we couldn't get the updates. Anyway, long story. Trying to get an AWS server up and running with IPv6, and that's supported, right? You read the AWS docs, and they support IPv6. Cool. I have a go-to buddy who's a PhD in network security. Whenever I have anything really hard to do, I go, Tim, hey, help me with this. And so Tim was helping me set this up. It took Tim an hour to get the server actually working. So yeah, IPv6 is there, and it all works, except that it doesn't all work. Anyway, you'll run into things. The devil's in the details when it comes to making specific things work with IPv6. But so thinking back to what life was like in the 2010, 11, 12, 13 era when we were all really enamored with rolling out IPv6, and you'd go to conferences, there would be talks about IPv6 security. I said, it's been years, literally, since I have seen an IPv6 security talk on the agenda at a big or small security conference. And so, if you're a paranoid security guy, it's quiet out there. Too quiet, right? So you wonder what's going on. So I started looking for shady IPv6 traffic. And this I thought was interesting. So if you've got access to worldwide traffic flows, and you look and you start to say, well, how much IPv6 traffic is out? Oh, look, we have IPv6 traffic floating around out there. And one of the things I look at is the port that's being used with the IP address. And so, yeah, we have a lot of 443 and port 80 traffic, but look at the size of the big dark green pie wedge there. It's like over a third, nearly a third, I guess, of the pie is other. That's the long tail, right? That is a very fat long tail. That's not what a long tail normally looks like. So a fairly high percentage of the random assortment of IPv6 traffic I can see is weird IPv6 traffic in terms of the port number. And if you contrast that with our IPv4 traffic, that's a normal long tail, all right? So again, the dark green pie wedge, which is the same other, there are thousands of different ports. These are weird ports, but that's like maybe 10% or less of the traffic, right? So percentage-wise, when I look at the traffic, yeah, there's a higher percentage of shady-looking IPv6 than IPv4 traffic. By volume, it's still mostly IPv4, but percentage-wise, looks shady. There's another interesting comparative stat. So I saw that a lot of the IPv6 addresses began with FE80, and I didn't know what that was because I was a noob. But my colleague who's an IPv6 guru said, well, that's a link local address. And I said, what's that? He said, it's like a 10 dot address. Oh, okay, I know what 10 dot addresses are. And so roughly 11.72%, nearly 12% of the traffic that was IPv6 was going to one of these. Okay, and that's fine if you're on an internal network, but I'm sitting out in the cloud. This is external traffic, right? So this is analogous to trying to go outside your network to reach a 10 dot address. Well, what does that even mean? 10 dot addressing only has, or 192.168 only has meaning within your network. If you're out on the public network, public web, trying to resolve a local address, you're doing something wrong, right? So that's roughly a 6 times as much network misconfiguration in our customer base when it comes to IPv6 traffic. Okay, I mean, we have still a sizable number of folks that haven't managed to stop their private IP address traffic from leaking out into the public web, but there's a lot more of it on the IPv6 side. Okay, one of the products that we can look at traffic for is called Packet Shaper, which is a network WAN-op packet shaping thing, hence the name. And it knows thousands of different network protocols. And normally I run into SSL, HTTPS, HTTP, which are the 2 yellow bars. But it's interesting that we have trace amounts of other protocols. And I don't know if you're like me, but when I see that there is such a thing as SSH and Telnet specific IPv6 protocols, like, did you even know that was a thing? And do you know if you have that on your network or not? Well, golly, you should look, because I would get really nervous if I had inbound Telnet or SSH IPv6 traffic coming into my network. So make sure you have something that can tell you if you have weird stuff like that going on. All right, so the stuff I knew about, that's stuff me pulling out of traffic and saying, okay, yeah, so there's evidence of weird stuff and misconfiguration going on. As far as classic attacks, there was this thing called the Slack attack back in 2011. And this is stateless address auto-configuration or something like that. The idea being that one of the things that IPv6 does differently than IPv4 is in IPv4 you either set up a static address, right, we've all done this 100 times with a web server or something, or you say I need a DHCP to give me an IPv4 address, and so I have to go talk to somebody on my network that can give me an IPv4 address because I can't do it myself. IPv6, because the address space is so big, it's very reasonable for a device just to say, you know what, I feel like giving myself an IPv6 address today. I think I'll do that. And the odds of colliding with anything are like infinitesimally small. It's not quite that simple. Again, I'm not an IPv6 guru, so anything I say may be inaccurate. How's that for a disclaimer? Anyway, so the problem was this was known, but it was a pain to set up, and so a group called NeoHapsis released an improved version at DEF CON 2013 called Sudden 6. The idea in both is the same. You've got a foothold, you're a pen tester, right? You've made it into a network, and now you want to do something cool, right? And so you set up a rogue IPv6 proxy right on the network. So you've compromised this server, and you load code on, and then the server can say, hey, network, I am an IPv6 proxy. We now can get out to the internet via IPv6. And again, if you go back to the 2010 kind of mindset where the whole world is moving to IPv6, you've got to be ready. Well, the major OS vendors like Microsoft and Apple and Linux heard that message loud and clear, and so they built their stuff to be aware of either IPv4 or IPv6. And so unless you specifically turned off IPv6 support in Windows, starting with Vista, it knew how to look for it, and it would prioritize that. So if it saw an IPv4 proxy, and that's how it's going out to the web, and then suddenly it hears that an IPv6 proxy has arrived, guess which one it's going to use? It's going to use the IPv6. It's like, hey, look at that. They told me that the world was going to upgrade, and it's happened, so I'm ready, so off we go on IPv6. Now, it's lying. Okay? It isn't really giving you an IPv6 path out to the internet. It's actually talking with you as all the other servers or the boxes on the network start sending it traffic. Say, oh goody, an IPv6 pathway. And it really isn't. It's using IPv4 to talk out to the web or the internet for you. It's just using IPv6 internally. But that puts them, the attacker, in the position where they can man in the middle all of the traffic. Now, they couldn't read encrypted traffic, but they could see where it was going, and they could change where it's going, right? And so there was a great quote in a magazine that talked about this article, and this is my pro tip for you. It's one more reason to enable IPv6 on your network rather than waiting for a hacker to do it for you, okay? So one of the best things you can do, and there'll be an action slide at the end that tells you to do this, is if you've never tried this, go home and have one of your engineers try to set up an IPv6 something on your network and document the pain points, right? Where does he get blocked? And it's really a bad situation if somebody can just set up an IPv6 thing on your network and it just works, right? You don't want to be in that situation unless you're already actively monitoring for it. But typically you'll run into one or more roadblocks trying to actually get out to the web, and the good news is that an attacker who's in your website, in your network, trying to do something like this should be hitting the same roadblocks. And so as long as you know where they are, you can watch for stuff like that. Okay? Interestingly enough, this was an old attack, okay? And in the 2013 era, if you went to any security conference and you looked on the menu of talks for something about IPv6, guess what you would hear about? You'd hear about sudden 6. And literally, I went to like 5 security conferences that year, and every conference had a talk from a pen tester about how to set up a rogue IPv6 proxy in a network and then exfil data and mess with their traffic and stuff. So everybody knew about this, and this was like the only thing that anybody ever talked about as far as a threat. So Fox IT in January this year figured out a new way to do this. And so instead of a rogue IPv6 gateway, it's a rogue DHCP v6 server. So if you set up the rogue IPv6 proxy, you broadcast to the network, hey, I am an IPv6 proxy. I can get you out to internet nirvana on IPv6. This sits and waits because the client machines on the network are saying, is there anybody yet who can give me an official IPv6 address? No? Okay, I'll ask later. So they're already asking, and all you do is you set up a box that's going to answer those queries and say, yes, you now have an official IPv6 DHCP server. Here is your official IPv6 address, and guess what? I will be your DNS server. And they're, oh, thank you. And this way there's not as much network traffic going around, it's harder to spot. And then they can abuse the proxy auto-discovery, and then again, they can control now where your traffic is going because they're the DNS server. So this is kind of cool, and it's nice that Fox IT provided snort SIGs, and so this is a really good place to start looking for weird IPv6 traffic on your network. And I'm like, okay, right, I knew about Sudden 6 and Slack Attack, and this is a cool, and the Fox IT is a cool new one, but these are like, I'm already in the network and doing exfil and stuff, and so I'm looking for like attacks coming in. It's like, are people attacking me? Anything out there on IPv6 coming in? And so I didn't know of any, and so I asked the Blue Coat research team that I knew really well because I was part of it, asked all of those guys, and I asked the Symantec teams. I tried like 3 or 4, Symantec's a huge company, like 3 or 4 different research teams. Hey, have you guys seen any cool attacks lately that involve IPv6 in any way? Yes, there were. There were 2 attacks I heard about. One was called, the Green Bug group was doing that, and Bachosens was doing IPv6. Okay, cool. So I got the reports, searched, Control F, search for IPv6, and there was literally 1 mention in each of these big long PDF white papers. And it just said, command and control traffic used IPv6. Okay, that's a start. And so I tracked down the researchers that did the reports and said, okay, tell me about this command and control traffic. So Greenbug is a Middle East threat actor. Officially, we don't attribute that to a country. In my opinion, it's Iran. But it's like, I don't know. because I'm not the guy that does the research on that. But anyway, so the report and Arbor also did a write-up on this because it was kind of interesting. And they said this uses IPv6, and then the sort of is from me. And by the way, one of the new things that wasn't in the RSA talk, but is now, is I have approval to let you know that Greenbug is still doing this, okay? So if you're the sort of organization that might be attacked by an Iranian hostile nation state, go check this in your network logs. Okay, so there's a bot called ISMDoor, and what it does is it shoots out a special DNS query. So it wants to know on this weird subdomain of this domain that the attackers control. They are the DNS, authoritative provider for that domain. Does this exist? So this query goes out of your network. It's just a DNS query, no big deal. And then the server says, oh yes, I know about that subdomain. Here is the address. Ding, ding. Now, that looks like a valid IPv6 address, and technically it would be, but this wasn't an address. This was just 16 bytes of data, okay? IPv6 addresses are nice little 16-byte chunks, and so it makes a great way to return data. And so then the bot would put an encoded message tacked onto that same subdomain, which is like a session identifier or a client identifier. How about this subdomain? Where is it located? And then the server would respond with another address, and so you're doing your command and control this way. And again, these guys still do that. So the other one is actually pretty cool. The researchers at Symantec that found this attack, it was using something like that. But they didn't know who this was. And so this had none of the hallmarks of any of the other APT groups, and they thought, oh, we found a new nation-state threat actor. No, it was one guy in Moldova who had figured out that this was a cool way to do command and control stuff. He was pirating software. And so again, sort of used command and control, IPv6. So the sample would be like this. Again, we're making a complex subdomain on a domain that I control as the attacker. I send this out. Where is this subdomain? And then it responds, in his case, with 2, because you can return multiple addresses, right? So there's 32 bytes of data, and so it's the same kind of thing. And I'm like, okay, those aren't IPv6 attacks. Come on, guys. But I'd exhausted my in-house resources, so I went to a couple of researcher communities that I'm a member of and said, hey, have any of you guys seen cool attacks involving IPv6? And I said, I will respect traffic light protocol, so if you give me something, you label it TLP green, I'm free to share, your name, the organization, details. Yellow, I don't mention your name or the organization that got hit, but I can talk about the details of the attack. Red, I can't really talk about much at all, just say there was this other attack, kind of a thing. And so I started getting stuff. This was cool. So we had a TLP yellow, so again, I can't identify the researcher who reported this, or what company he works for, where he'd seen this, but there was a Brazilian site that got hacked earlier this year. This is kind of like a Forbes.com, it's a financial news site. And so they had an injected link on their page that looked like that, but with T's instead of X's on the protocol there. And the idea is if that : FFFF, that tells the browser to ignore the first 12 bytes, they're basically masked off. First 12 bytes are masked off, and just the last 4 bytes, which would be an IPv4 address, right? So that's how you represent an IPv4 address in IPv6 format. And you can see that the 12 hex would be an 18, right, in decimal. So that's an Amazon address, and then if your browser went there, you'd be dropping Adobe Flash Player.exe. Yeah, all right. Okay, that's still not an IPv6 attack, right? It's IPv4, just using IPv6 for a little bit of obfuscation. So then I heard from an engineer who said, well, on a previous job, a few years back, he says, we decided we were going to look for shady IPv6 traffic in our organization. And if I told you which organization it was, you'd get very excited, so I'm not going to tell you. He said, we found some. And if you remember from my little history slide, one of the papers from US CERT in 2005 talked about being aware of tunneling. So you could take an IPv6 because the infrastructure is not there in 2005, right? So you can make IPv6 traffic work over IPv4 by embedding it in an IPv4 header, right? And so it's tunneling through the IPv4. He said, we found some of that. He says, but we didn't know what it was doing. We couldn't tell, right? But we talked with it about management, and management didn't think it was that big of a deal, i.e. they had bigger problems, more obvious things to worry about. And so he says, we never knew what it was, but it was there all those years ago. Okay, that might be an IPv6 attack, we don't know. A couple more came in. There was a DDoS tool announced in an underground forum that one of my colleagues reported to me. And this was a rather arrogant cyber criminal bragging about how this weapon would bring the internet to its knees. And the researchers kind of picked it apart and said, oh, it's not that big of a deal. But another guy under TLP Red reported, he says, yeah, back in November of 2016, our organization was hit by a multi-vector big DDoS attack, and that did include some IPv6 stuff. Okay, well, that's cool. And following the threads led me to a blog post. So that's TLP White. It's like public, already out there. So there's a fun guy. He's a fun researcher. He's a German-speaking, but he lives in Japan, and English is actually his third language, so you'll have to excuse the English in the bottom box that comes up. But he's part of this little group called Malware Must Die, which is like an awesome name for a good guy organization. And he's a reverse engineer, and so he was taking apart a piece of malware that showed up Mirai style, like a Internet of Things type botnet. And he's reverse engineering this, and he said, hey, this bot actually has IPv6 DDoS stuff along with the IPv4. And that's his little summary. So you can send DDoS packets under either channel, and you can do IP spoofing under either channel. Okay, well, that's an IPv6 attack. More recently, when I was looking to say, okay, has there been anything in the IPv6 landscape since I did the slides for RSA? Yes, there was. There was a big IPv6 DDoS attack on February 28th. And the best write-up, you can just Google IPv6 DDoS, and this will be at the top of the stack. The Register had a really good write-up. So this, the company that reported this said there were about 1,900 IPv6 nodes that were participating with IPv6 traffic in the attack. It wasn't the main part of the attack, and the Register said, first IPv6 DDoS. Well, it wasn't the first IPv6 DDoS. But they did point out that again, we're better at setting up networks than we are about like securing them and getting things working. Really good point. Okay, a lot of DDoS attacks. One of the common techniques you'll see is a DNS reflection attack, right? Where as the attacker, I send a DNS query to an open resolver that will respond to anybody, not just its own network. And then I say, and this IP over here is who wants the information. And so then it takes this little request and it takes this big blob of data and shoots it off to the victim IP. And if you tell hundreds or thousands of open DNS resolvers, hey, here's my query, and send the results over here, they all start bombarding the victim. And the traffic coming out of each server is way bigger than what you put in, hence amplification attack. Well, you can scan for open DNS resolvers in the IPv4 space. That's not hard to find. We can find them, and we've been trying to get them shut down for years and years and years and tell people, look, don't do this. Don't configure them to respond to any requests. The point is in IPv6 land, you can't scan IPv6 land. The scale of the number of possible addresses is just overwhelming. And so how are we going to find the open DNS resolvers in IPv6 land, which I thought was an interesting question. So it's like I said, this wasn't the first attack. Summary slide, time to wrap up. Okay, so how much should you worry if you're an IT guy? I would say medium, because there's just not a lot of really scary stories out there, all right? Anyway, so then what do you do about it? Okay, so when you go back home and say, oh, we should probably do something about IPv6, well, there are two modes of thought. One says, block it all. I like that. Because you probably don't actually need IPv6 on your network yet, and so anything trying to use it is either shady or misconfigured, right? That's the block it all reasoning. The other line of thought says, no, make sure you have visibility and then monitor. Keep an eye on it. Because then even if there's no flood of malware activity now, you'll be ready. And if you just block command and control traffic channel, the odds are that the bad guy has a backup. Actually, he probably has 2 or 3 backup mechanisms. And so if you block the one you know about, you just force him to use another channel that you may not know about, right? So, action slides. I still believe in visibility and monitoring. I think that's a good way to approach life. So, The current threat landscape, as best as I can tell from querying all of my friends and not so friendly friends, it's not that urgent, okay? So if you have bigger problems, and probably all of you do, all right, work on those and just try to block IPv6 for now. But make sure, okay? So within 90 days, actually assign somebody. If you think you're blocking IPv6, make sure. Try to set up something using IPv6 and verify that, no, it's not able to get out on the network. If you're monitoring, or you think you're monitoring, again, make sure. Set something up and verify that you are seeing its traffic at the points where you think you will. And then you can keep an eye on it because you know then what's normal, what's not. Thank you. Do I have time for questions? No. If it's really fast, I guess while I'm unplugging, you can ask me a question. But thank you so much again for coming. I do not see any